Welcome to G Fun Facts Online. Today, we're traveling back in time, not by hundreds or thousands of years, but by billions. We're going to the chaotic dawn of the cosmos to witness some of the most violent and monumental events the universe has ever produced. Cosmic collisions on an unimaginable scale. Forget a simple fender bender. We're talking about entire galaxies, each containing billions of stars, smashing together. Recent discoveries have peeled back the curtain on this primordial era, revealing galactic pileups that are forcing us to rethink how the universe's grandest structures were built. Our story begins with the James Webb Space Telescope, a time machine peering into the universe when it was just 800 million years old. In this ancient darkness, Webb spotted something so rare it's been nicknamed JWST's Quintet. This isn't just a trick of perspective, with galaxies appearing close together from our viewpoint. These are 5 galaxies, physically bound by gravity, locked in a dance that will end with them merging into one single massive entity. Finding a system this complex, this crowded, so early in the universe's history, is a huge deal. Our best computer simulations of the cosmos suggest that a 5-galaxy merger should be exceptionally rare at this point in time. Wada Hu, a lead researcher on the project, even suggested that astronomers might have just been incredibly lucky to spot it. But this discovery is more than just a lucky snapshot. Webb's Near-Infrared Camera, or NIR-CAM, revealed a vast halo of gas enveloping the entire system. This halo is the smoking gun, the undeniable proof that these galaxies are interconnected. A true family on a collision course, they are destined to become one. And these aren't calm, serene galaxies. The immense gravitational forces at play are tearing them apart and simultaneously triggering furious bursts of star formation. The tug of war between the galaxies creates shockwaves that compress enormous clouds of gas, igniting a firestorm of new stars. This process, known as bursty star formation, is incredibly intense, but also incredibly wasteful. It's like flooring the gas pedal in a car. You get a huge burst of speed, but you burn through your fuel at a terrifying rate. This observation might solve a long-standing astronomical puzzle: the mystery of red and dead galaxies in the early universe. Astronomers have been perplexed by the discovery of massive galaxies that seem to have stopped forming stars very early on. How could a galaxy run out of gas so quickly? JWST's Quintet provides a live-action demonstration. The intense, merger-driven starburst could consume the entire gas reservoir of the system in a cosmic blink of an eye. Once the fuel is gone, star formation grinds to a halt, and the newly formed giant galaxy becomes quiescent, or dead. We are essentially watching the birth and potential future death of a massive galaxy, all in one observation. But if a 5-galaxy pileup sounds impressive, hold on. Lurking even further back in time, when the universe was about 1.4 billion years old, is something that makes the Quintet look like a minor traffic jam. Meet SPT 2349-56. This isn't a handful of galaxies, it's a galactic megalopolis under construction. It's a full-blown, multi-lane cosmic highway catastrophe. Discovered initially by the South Pole Telescope and later studied in breathtaking detail by the ALMA Observatory in Chile, SPT 2349-56 is a protocluster, a baby galaxy cluster of epic proportions. It contains at least 14 young, star-forming galaxies, all packed into a region of space only about 3 times the size of our own Milky Way. And when we say star-forming, that's a massive understatement. The individual galaxies within this structure are churning out stars at rates up to 1,000 times that of our galaxy. The combined star formation rate of the entire system is a mind-boggling 10,000 times that of the Milky Way. This frantic activity is powered by an enormous reservoir of fuel. Recent observations have uncovered a colossal, previously hidden fuel tank of cool molecular gas surrounding the protocluster's core. This tank holds enough raw material to keep this star-making frenzy going for another 400 million years. Finding this gas was itself a surprise. Normally, this kind of star-forming fuel is found concentrated inside galaxies, not floating in a massive cloud around them. The very existence of SPT 2349-56 throws a wrench in our standard models of the cosmos. According to our leading theory, the hierarchical model, the formation of massive galaxy clusters should be a slow, gradual process, taking billions of years. Small things form first, and then they merge over eons to create larger structures. But SPT 2349-56 seems to have skipped a few steps. It got this big this fast, in what one of the lead researchers, Tim Miller, described as a bit of a mystery. It wasn't built up gradually. It seems to have collapsed into existence with shocking speed. This suggests our models of the early universe might be missing a key ingredient, some mechanism for accelerated growth that we haven't yet accounted for. The future of this protocluster is just as dramatic as its present. Simulations predict that all those 14+ galaxies will eventually merge into a single gargantuan galaxy, what astronomers call a brightest cluster galaxy, or BCG. This colossal entity will sit at the heart of what will become one of the most massive galaxy clusters in the entire universe today, something comparable to the well-known Coma cluster. So, by studying SPT 2349-56, we are getting an unprecedented look at the birth of a cosmic giant in its most formative stage. And where there's this much gas and activity, you can bet supermassive black holes are also feasting. The same dense gas that fuels the starbursts also funnels down to the centers of these galaxies, feeding the black holes that live there. X-ray observations have already detected at least 2 active galactic nuclei within the cluster, confirming that these cosmic engines are switched on and growing rapidly. So what does this all mean when we put it together? The discovery of both JWST's Quintet and the protocluster SPT 2349-56 aren't just isolated curiosities. They are key pieces of evidence that are forcing a major reevaluation of how galaxies, especially the biggest ones, come into being. The traditional bottom-up hierarchical model, where small things slowly build big things, struggles to explain these massive, mature structures appearing so early in cosmic history. These discoveries lend weight to alternative ideas. One is a phenomenon called downsizing, where the most massive galaxies actually seem to form their stars earlier and faster than smaller galaxies. Another is the monolithic collapse scenario, where a single, gigantic cloud of gas rapidly collapses to form a massive galaxy in one go, rather than through a series of smaller mergers. These ancient pileups might also solve another JWST puzzle. The telescope's first images revealed galaxies in the early universe that appeared to be surprisingly massive and mature, almost impossibly so. But new simulations suggest these galaxies might not be as heavy as they look. Instead, their incredible brightness could be the result of these short-lived, intense bursts of star formation, like the ones we see in the Quintet and the protocluster. This bursty activity makes them shine incredibly brightly for a short time, making them appear more massive than they truly are. It's like seeing a flashbulb go off in the distance. The brief, intense light might make you misjudge the size of the source. None of this would be possible without the incredible technology we've developed. The James Webb Space Telescope's power lies in its huge mirror and its sensitivity to infrared light. As light from the early universe travels across expanding space, its wavelength gets stretched into the infrared part of the spectrum. Webb is built specifically to see this ancient reddened light. Then there's the Atacama Large Millimeter/Sub-Millimeter Array, or ALMA. This array of 66 radio telescopes in Chile is a master at detecting the faint glow from cold gas and dust, the raw ingredients for stars. It was ALMA that was able to resolve the single blurry smudge of SPT 2349-56 into a bustling city of 14 distinct galaxies. And we can't forget the South Pole Telescope, which first spotted the protocluster, or the Hubble, Chandra, and Apex telescopes, which all added crucial pieces to the puzzle, from visible light images to X-ray detections of black holes. In conclusion, the discoveries of JWST's Quintet and the protocluster SPT-2349-56 have opened a new window into the violent, chaotic, and transformative youth of our universe. They show us that the construction of the cosmos wasn't a slow, gentle process. It was a demolition derby. The grandest structures were forged in the fires of cataclysmic collisions, growing faster and earlier than we ever thought possible. This is cosmic archaeology, but instead of digging up stones, we are looking back in time at blazing furnaces of creation. And this isn't just a distant academic story, it's our own origin story. The iron in your blood, the calcium in your bones, the carbon in every cell of your body were all forged in the hearts of stars. Those stars were born in galaxies. And those galaxies were shaped, built, and brought into existence by the very same titanic collisions we are now witnessing across billions of light years. In the silent expanse of the early cosmos, creation came from destruction, and order emerged from chaos. Thanks for listening to G Fun Facts Online.